Okay, so in this video, I'm going to show you an example problem on how to find the arc length of a curve like this. So here is our sample function. It's y is equal to the quantity x squared plus 2 to the 2/3, or to the 3/2, all over 3. And that looks like this. So we want to find, basically, and this keeps going up off the screen this way, but we basically want to find how long this line would be if it was stretched out. Well, we have a formula which is the arc length is equal to the integral of a to b, or the integral of a to b, square root 1 plus f prime of x squared dx. So, and the proof of this is actually kind of interesting, but I will leave that for another video if I do that. So, of course, a and b are your bounds. So we want a, this is going to go from 0 here. So here's a to b. So there we go. So a is equal to 0, b is equal to 3. Now, whenever you have your lower bound being 0, it's always kind of fun because it makes evaluating the definite integral be a lot easier. So what's our derivative of the function? F prime of x is the derivative. So what's the derivative of this? Well, let's rewrite this. F of x is equal to 1/3 times x squared plus 2 all to the 3/2. And then we just hit this with a chain rule. 1/3 times 3/2 times x squared plus 2 to the 1/2 times 2x. So this would be, these cancel out, this cancels out, you get x times the square root of x squared plus 2. Okay, so here is your derivative. So there you go, f prime of x. So we continue on, plug this into our formula now. So L is equal to the integral from 0 to 3, the square root of 1 plus this squared. So what's that squared? Well, x squared times, and when you square a square root, you get whatever's inside the square root. So x squared plus 2 dx. So now we have L is equal to the integral, and we can just simplify this out and distribute it, the x squared over. So the square root of 1 plus x to the 4th plus 2x squared dx. Now basically at this point, because we want to simplify this, we have to basically get either a perfect square in here, or b, something that, is really easy to evaluate inside of a square root. Do a u sub. We don't have anything outside to do a u sub with, though. And I suppose that when you get further along in calculus, you can do a trig substitution, but I'm not sure about that. So I'm going to increase my canvas size. Hang on. Okay, so now I have a bit more room. So length is going to be equal to the integral from 0 to 3, square root of, now this is actually going to be a perfect square, and we can see that quite easily, because if we take x squared plus 1 and square that, well, we get this expression inside there. So this is the perfect square. Now what happens when you take the square root of something squared? Well, you just get that something back. So this length is going to be the integral from 0 to 3 of x squared plus 1 dx. And of course this is a very easy integral to evaluate, because we have the length is going to be from 0 to 3 x cubed over 3 plus x. Now this is an integral. We're integrating here. So this would be evaluated from 0 to 3. So the length is going to be, we can just don't have to worry about plugging in a 0. So we get 3 cubed over 3 plus 3, which is going to be 9 plus 3, which is equal to 12. So, if you were to come up here and hammer out this curve, it would stretch out along the x-axis. If it was a straight line, it would stretch out for 12 units. And that is an example problem of finding the arc length of a curve.